Okay? Anybody extended time, fill the form out now. All right, so here we go. Practice test 1. Our quizzes should be turned in. We should be done. Here we go. Number 1. The test is going to be part no calculator and part with calculator. Okay? So this is the no calculator part. So here we go. It says change into degrees. You guys have been doing this in lots of different problems. What do we do to change that into degrees?
Equals 180.
You know pi is 180. So you're just going to put 180 in there. And then if this is no calculator, you'll have to do a little arithmetic on your own. So you can do 180 times 5, or excuse me, 180 times 3. And then divide that by 5. So however you do it, 108 is the answer. All right, how do we change it? We just put 180 in for pi, right? Now the next one's not so easy. How do we change 250 degrees into radians? What does that involve?
X over 5?
It's something like that. It's pi over 180 equals x over 250. Pi over 180, x over 250. So then we cross multiply, and 180x equals 250 pi. Remember, you're solving for x. So we're going to divide by 180. The zeros cancel. And I think that's all we can do, right? So our answer is 25 pi over 18. Okay, that's it. Find the measure of the arc. So when they talk about an arc, they're talking about something like this, right here. We're going to find the measure of the arc determined by an angle of 40 degrees in a circle with a radius of 10. Who remembers anything about this? Yeah.
Radians, radius.
Okay, so Q remembers that arc length equals radius times radians, right? Now what's the problem though? We have a problem. What's the problem?
The degrees is
The angle is in degrees. And in order to use the formula, it has to be in radians. Well, didn't I just do a problem like that? Didn't I just change a degree into a radian? So pi over 180 equals x over 40. Cross multiply and divide by 180. So zeros cancel. What about 4 pi over 18? Does that break down anymore? 2 9. So your angle is 2 pi over 9. So often, guys, when I grade this question, remember, this is the practice test. So what does that mean? Everything here is on the test. So this is going to be a test question. And so often when I grade it, kids will put this in the answer blank. That's not the answer. That is this angle right here in radians, right? We just changed that angle into radians. So now we can pop it into our formula. 10 times 2 pi over 9. That's going to be the answer. Arc length, radius times radians. So that's 20 pi over 9 inches. That is the final answer of the problem. So this is tricky because it's 2 steps. The first thing you have to do is change that angle into radians, and if you can remember Hugh's formula, you'll remember to do that, because it says radius times radians, right? All right, number 4. Now, this is written a little bit tricky, so let's see if we can figure out what's going on here. I'm getting so old. All right, so we're going to find sine, cosine, tangent, cosecant, secant, and cotangent. We're going to find all these things. Well, what do we know? We know that tangent is 1/2, and then we have this. What do you think that means? What is that telling me, Jacob?
Angle is greater than 180 but less.
That's telling me where to draw my picture. That's telling me when you draw your picture, you gotta draw your triangle between 180 and 270. Doesn't that mean it's down here? Theta is the angle. And they're telling you in the problem where to draw it. Now, I've done that before too. Tell you where to draw it, but I usually say put it in quadrant 2 or something, right? This is the same thing, only it's not giving you a quadrant, it's giving you angle parameters. You're between 180 and 270. This is probably easier for you. So here's my angle. What do I know about it? I know its tangent is 1/2. So opposite over adjacent, here's the angle. Opposite over adjacent is 1/2. But those are both negative. But Mrs. Ford, it doesn't say they're negative. Well, because when you built the fraction, didn't the negatives cancel? How do I know they gotta be negative? Left and down. Now what? Pythagorean theorem. Pythagorean theorem says 1 squared plus 2 squared is c squared. Looks like c is going to be the square root of 5. Now, can we fill all this in? Yep, because this is opposite, this is adjacent, this is hypotenuse. Here we go. So, katoa, sine is opposite over hypotenuse. I'll fix it later. Cosine is adjacent over hypotenuse. Tangent they gave me. Now what about these guys? They're the reciprocals. Cosecant is the reciprocal of what? Sine. So this is going to be root 5 over -1. This one's going to be root 5 over -2. And this one's going to be 2 over 1. Now, if I want to get total A+ credit, I'm going to go back and clean up the ones that need to be cleaned up. So this is going to become negative root 5 over 5. Negative 2 root 5 over 5. Negative root 5. And 2. Now everything is cleaned up totally 100%. We're ready to go. Anybody have a question about that? All right, find the exact value. We've practiced a lot of this the last few days. Find the exact value of cosine 3 pi over 4. All right? Who remembers how we start? Change pi into 180. So we have 3 180s divided by 4. That's gonna be 135. I've done a lot of them, so I just know that's 135. That's what it's gonna come out to be when you put 180 in for pi. All right, is everybody okay with that process? You know you're supposed to put 180 in for pi. Okay. Now, what do we do next? That is not the answer. The answer is a cosine. The answer is adjacent over hypotenuse. That's the answer. So I'm gonna draw a picture because I need a triangle. And I know that's 90 and this is 180, so 135 is right here. And I'll make my triangle. Now, I need to know, in order to do some labeling here, I need to know this angle right here, this purple angle, that's the key. That angle is formed by these two markers. Would you agree with that? This marker is 135. This marker is 180. How much is between 135 and 180? 45. Now, does that do me any good? Yes, because that tells me my sides are 1/√2. Right? Anything negative, take care of that before we go on. Anything negative in there? The bottom one is negative because it's left. What's our rule about the hypotenuse? Never negative. Now I'm ready. Adjacent over hypotenuse. Adjacent is adjacent is -1, and hypotenuse is √2. So if I want to get an A plus, I'm going to clean that up, and there is the final answer to the problem. Remember, when they're asking you for a cosine, your answer needs to be a fraction. Adjacent over hypotenuse. All right, let's try this. Tangent, 5 pi over 6. What's the first thing we do? Take care of that angle, so that's going to be the tangent of 150. Y'all get 150? That's not the answer. Tangent is going to be opposite over adjacent, right? That's going to be my answer. So I'm going to draw my picture. This is 90, this is 180. Won't 150 also be over here? Like 135 was over here? I'm going to drop that perpendicular down. That's the angle I want. It's 30 degrees. Kids, it's so easy. 150 to 180. Yesterday somebody said, well, what about 90? Who cares about 90? My marker's on 150 and 180, right? So that's a 30, which means that my opposite is 1, my adjacent is -√3, and my hypotenuse is 2. And now I can answer the question. Tangent is opposite over adjacent. Opposite over adjacent. Did you get 1 over -√3? And if you want to get full credit for that, you're going to rationalize it and make it -√3 over 3. All right, I think we got a couple more of these. Sine pi. Tell me about sine pi. That's just sine 180. And I know, I'm not done, because sine is a fraction, so I need opposite over hypotenuse. That's what I think of when I think of sine. So I'm going to go ahead and try to draw my angle. uh-oh. I can't draw a triangle. I can't do opposite over hypotenuse. I have to do something different. Because isn't this my angle right here? So what do I do when I can't draw a triangle?
Circle.
I draw a circle. And the radius of that circle is always 1. So I can label every single one of these points. But I really only need this one in this problem. What are the coordinates of this point?
Actually,
-1, comma, 0. So that's x, and that's y. Now, I can't do opposite over hypotenuse, because I only do that if I have a triangle. What do I do when I'm in the circle? Y over r. Y over r. What's my y? 0. And 0 over 1 is just 0. So the answer to that question is 0. All right, one more. How do we do this one? Don't we start the same way? So what's 5 pi over 3? Anybody figure it out yet? 300 degrees. So okie dokie. Now where's 300?
Fourth quadrant.
300's over here. So our perpendicular goes up. We got a triangle this time. We only do the circle thing when our angles are out here. Now, I need this angle right here.
60.
It's 60 degrees. Does everybody see that? It's a 60-degree angle. Which means this is root 3, this is 1, this is 2. Is anything negative? We always have to stop and ask ourselves that question. This is negative. Oh boy. Secant. Cosine is adjacent over hypotenuse. So hypotenuse over adjacent, 2 over 1 or 2? Oh, there's a couple more here. These two are different though, guys. You see how these two have that funny notation? Does anybody remember what that funny notation means? This is a quadrant 4, and it means find the angle. Your answer to this question is going to be some degrees. When you see that little inverse notation, that means our answer is some degrees. All right, now I told you to draw it in quadrant 4. What does this tell me? This tells me something about my triangle. What does it tell me? Opposite is negative root 3 and hypotenuse is 2. Which means that's 1. And the angle, which is what I'm looking for, the angle is 60. But since it's down 60, the answer is going to be negative 60 degrees. If that had been quadrant 1, that is 60, right? That would be 60. But since I came down to be in quadrant 4, it's negative 60. You must remember that notation means find an angle. Alright, one more. This one's gonna be in quadrant 2. This one is in quadrant 2. So here I am in quadrant 2. What do I know about the triangle? Adjacent is -1 and hypotenuse is √2. Do you recognize that angle right there? Isn't this a 45-degree angle right there? Now, on my system here, this is 90, this is 180. Can I say that the answer is 45 degrees? No, because clearly if I'm in quadrant 2, I have to be between 90 and 180. Would everybody agree with that? So whatever label goes here on this angle, that's going to be my answer. Any idea on what that is? 135. Now, for those of you that have your heads down, your eyes closed, slouching around, how did we get 135, Angie?
Yeah,
How did you get 135?
I subtracted 180 from 45.
Exactly. She said if I went all the way over to here, it'd be 180. I stopped here. 180 minus 45 is going to give me 135. Beautiful. Beautiful, beautiful. Now we got a tricky one. We're going to do a couple really easy ones here in a minute. The graphs are easy. But this is a little bit tricky. So this says the sign is positive, greater than 0 means positive, and the cotangent is negative. Now there are lots of ways you can do this. One way you can do it is just to think in this quadrant, right here, isn't every side positive? Well, I already know I need something to be negative, so that's not going to work. That's not going to be the quadrant. So let's come over here. In this quadrant, I know this is always positive. Negative, positive. Is that right? So let's check that one. Is the sign, this is your angle, is the sign still positive in this quadrant? Is the sign going to be positive in this quadrant? Yep, so that works. How about the cotangent? What's cotangent? Reciprocal of tangent? So it would be adjacent over opposite. Is that negative? Is adjacent over opposite negative? The answer to the question is quadrant 2. There's only going to be one quadrant that meets both qualifications. I knew it wasn't quadrant 1 because there was a negative involved. So I came over here and it happened to work in quadrant 2. If it didn't work in quadrant 2, I would come down here and try this quadrant. And then I would come over here and try this quadrant. One of them's going to work. All right, we're almost done. This is the last no calculator part. We're going to graph. You are allowed to do this however you want. However you want to graph, that's up to you. A suggestion I have is that maybe you start by going through and just sketching in the shape of each one. You get half credit for having the right shape, so let's just get the shape in there. So this is a cosine. What do you remember about the shape of a cosine? Jacob?
Bill will probably have so.
Yeah, starts up here, does half my hill, then my valley, oops, and then the other half of my hill. I'm over a little bit too far. Okay? So that's the shape of my cosine. When I label where it crosses the bottom of the valley, where it crosses, and where it ends. Alright, tangent. Let's do this shape. Remember what this shape looks like? What does this shape look like? Asymptote, asymptote, squiggly line up through the origin. And be careful with this one, it's a negative sign. What does a negative sign look like? Starts at the origin, but it goes down first and then up, because it's negative. So low point where it crosses, high point where it ends. Is there any question about the shapes? Shapes are good? Alright, then we're ready to start labeling. So back to our cosine. What does that 2/3 tell me there in front? These are 2/3. And oh, by the way, that's the amplitude. Now, what do I know about these guys? I know what they're supposed to be. They're supposed to be 90, 180, 270, and 360. That's what they're supposed to be, always, from around the circle. But what's happened? We divided by a 4th, which is the same as times seen by 4. So they're going to be 360, 720, 1080, and 1440. Now, I need you to do this right. This is where you put the correct labels. Down here, if you want to work, this is where you put your work, down here. Or someplace else, I don't care. But this is where the correct labels go. What's my period then? My period is start to finish, and it finishes at 1440. Point for the shape, point for the labels, a point for this. Easy enough? How about our tangent? Good news is, tangent does not have labels here, because the tangent does not have amplitude. And you might say, oh, but Mrs. Ford, there's a 2 out there. I know, there's no amplitude. I can put a 5 out there, I can put anything out there. The only time I need to pay attention to that is if it's negative, because a negative would turn it upside down. What are these labels here supposed to be? Did I do anything to change those? No, I didn't. We don't have anything today. No, I didn't do anything to change those. So those are it, negative 90 to 90. So what's my period? 180. What are these labels? 3 and negative 3, because my amplitude is 3. These labels are supposed to be 90, 180, 270, and 360. But what have I done to them? I divided them. And I divided them by 2/3. So 90 divided by 2/3. We are seniors in high school. We can do this. That's 90 times 3/2. 90 times 3 is 270. And 270 divided by 2 is 135. So this label is 135. Now, I'll give you a little hint. I don't think we've talked about this before, but you probably have noticed it. These are all evenly spaced. So as soon as I put a 135 there, I know this one is gonna be 270 because it's another 135. And then this one is gonna be 405 because it's another 135. And then this one is going to be 135, 540 because it's another 135. So if it's easier for you to just add, you can do that. Or if you want to do all this arithmetic, you can do that too. So your period's 540. Your amplitude's 3, and your period's 540. I don't want to hear any whining about that arithmetic. You guys, you got out of 5th grade somehow. Right? You can do that. All right, get your calculators out. Here we go. Convert to degrees, minutes, seconds. This is probably the easiest thing on the whole test, right? Oh, did someone give me my calculator back? Can you give it back to me?
I'll put it up there.
You did. I know you did, but I want you to be using it. Okay? I want you to be using it. Okay? Practicing with it. So, how do we type that into my calculator? I think they're gonna play that stupid music and I gotta make sure I'm here to turn this off if they do. Alright, so what do I type into my calculator?
Did you hand out a separate sheet of paper?
They handed out the practice test a long time ago. How do I type it in? 18.775 second angle DMS. Enter. And it should say. Alright, so 18.775 second angle DMS. Did you get 18 degrees, 46 minutes, and 30 seconds? Okay, easy peasy.
Round it, Miss Round.
Huh?
Yeah, round it to 10,000. We already rounded?
I'm doing 8. 8 doesn't need rounding. It's 18 degrees, 46 minutes, and 30 seconds. Yeah, we haven't done number 9 yet. But we're getting ready to do number 9. Okay? So, right now, your calculator is set in degrees. Okay? So let's do the degree problems first. So is A degree problem? Does it have a degree mark? Okay, so we're ready to go. We're going to do A. So we type sine 28 second angle degrees 14 second angle minutes. And this one, Caius, we're going to have to round off. And it says round off how? 10,000. So 0.4731. 10,000th is 4 places. Did you get point? You're in radians. Did you get 0.4731? Okay, perfect. Now, we cannot do B right now. Okay, we can't do B right now. Or C. but we can do D. Why am I picking and choosing? I'm picking and choosing the ones that have degree marks because my calculator is in degrees. So how do I type a secant into my calculator? 1 divided by cosine 19. And 1 divided by cosine 19. Kaden got 1.0576. Is that good? Perfect. E. That's a degree. I can do it. Cosine 98. If you missed that one, you are like hopeless. Cosine 98. Negative 0.1392. I'm reading upside down, so I could be incorrect. Is that what you got? And then F, we can do that one, that's a degree. So F, how do we put in a cosecant? 1 divided by sine, so we literally type 1 divided by sine, 15 second angle degree, 19 second angle minute, and 11 alpha plus 3.7849. 3.7849, does that sound about right? Okay, now we're going back to our calculator. Back to the calculator and go to mode, and change it into radians. So press mode, highlight radians. And we're gonna go back and do the problems that don't have degrees. So that would be problem B. Type tangent, 1.15, 2.23, is that 2.2345?
Yes.
Oh, that's cool. 2.2345. Something to talk about at lunch with the math teachers. All right, and then C, what do I type in for C? Second cosine 0.376. 1.1853. Is that right? Okay, now I want you to look at the very next problem, number 10. Do you see that angle? That angle has a degree mark on it, doesn't it? So what do I need to do right now?
Change back to degrees.
Go back to my calculator, press mode, and change it into degrees. Kids, the only problems that use radians on this test are the ones like we just did in that section. Every other problem on the test is going to be in degrees. So make sure you're in degrees. All right, we're going to do this problem. Gabe, you act like you can't wait to get out of here. It's hurting my feelings. Take a look at this angle, at this triangle. What function are you going to use? Here's your angle. What function are you going to use? What do we got? Adjacent, hypotenuse. So cosine x equals adjacent over hypotenuse. Wait a minute. X is the angle. What does that mean? What button do I have to press if x is the angle? Second cosine. So second cosine 11/14 is 38.21 degrees. Would you agree with me? 38.21. All right, we'll keep going.